Now we're going to talk about another option when you're trying to solve for a limit algebraically. Sometimes when you try to do a direct substitution, you get something called the indeterminate form. It's called indeterminate because you cannot determine the limit. What you end up with is 0 divided by 0. And that answer is not 0. It does not exist. It's a red flag to you that there's something else that needs to be done to the problem. So here's an example. Let's talk about the limit as x goes to 2 of the quantity x squared minus 4 all over x minus 2. All right, my first step is always to try direct substitution, so I'm going to try direct substitution again. So that's going to give me 2 squared minus 4 all over 2 minus 2. Well, 2 squared minus 4 is 0 because 2 squared is 4, and 2 minus 2 is 0. Little bells and whistles need to start going off right now. Ding, 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 ding. This is the indeterminate form. It means I need to do something else. And the something else that you try to do first is you try to do some factoring. All right, so we're going to take this expression, the limit as x goes to 2 of x squared minus 4. Well, let's see, x squared minus 4 really is x minus 2 times x plus 2, and it's still over x minus 2. I now notice that I have a common factor that I can get rid of. So now I can represent this limit as x goes to 2 of x plus 2. Direct substitution would give me 2 plus 2. That would give me 4. Now, what's going on with this whole factoring out the x minus 2? Well, if you remember from your pre-calculus days, when you have a common factor in the numerator and the denominator, it means that you have a whole. This graph has a whole at, set the denominator equal to 0, x minus 2 equals 0, gives me x equals 2. Find the y-coordinate by plugging that 2 into what's left. 2 plus 2 is 4. Oh, this particular function has a whole at 2, 4. It's going to look very linear, except for the fact that there is going to be a hole at the spot where 2, 4 is. So if I look at this graph, when I look at the graph, I'm going to get a picture something like this, and at the point 2, my limit as I approach 2 from the left-hand side and I approach 2 from the right-hand side is still going to be that same value of 4, but I don't have an actual function value at 2. That's what that hole represents. One of the most important things that you've got to remember that we went over in pre-calculus last year was how to factor a perfect cube. That might be an expression like x cubed minus a cubed or x cubed plus a cubed. Perfect cubes are binomials where each part is a perfect cube number. And if we remember how this is done, in the first problem, I'm going to have a binomial part and a trinomial part. The binomial part is the cubed root of each of my pieces. So the cubed root of x cubed is x. The cubed root of a cubed is a. So I have x minus a. The next part is square the binomial first term, multiply those two with the opposite sign, and square the binomial second term. Hopefully you remember that from last year. So this one would be x plus a times x squared minus ax plus a squared. And this one you really need to know by heart. Just like all of you know what to do with x squared minus 4, you know it's x plus 2, x minus 2, you should also know what to do with, for example, something like x cubed minus 27. All right, x cubed minus 27 is going to look like the binomial part would be x minus 3. The trinomial part would be x squared plus 3x plus 9. This piece will never be further factorable. That's just the way it's going to stay. So you'll get those two pieces. So you might see a problem where you have to find the limit as x goes to 4 of x cubed minus 64 all over x squared minus 16. Direct substitution tells me that if I try to do plug 4 in for everything, I get 4 cubed minus 64 over 4 squared minus 16. 4 cubed is 64. 64 take away 64 is 0. 4 squared is 16. And 16 take away 16 is still 0. Ding, 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 ding. Indeterminate form. I need to do more. My do more is I'm going to factor this expression. So we're going to rewrite this expression. The limit as x goes to 4, let's see, x cubed minus 64 would be the cube root minus the cube root times the first term squared, the 2 multiplied with the opposite sign, this part squared, all over, I know x squared minus 16 is x minus 4, and x plus 4. And now I notice that the thing that was causing me a problem was when I substituted 4 in. Well, now when I take this expression, I notice I have a common factor of x minus 4. That means that I can factor out the issue that was causing me problems. And now I can complete my direct substitution. So now I'm going to get 4 squared plus 4 times 4 plus 16 all over 4 plus 4. Well, 4 squared is 16. 4 times 4 is 16. 16 plus 16 is 32 plus 16 is 48. 4 plus 4 is 8. So that means my limit is 6. The biggest thing to remember when you get 0 over 0 is that you need to do something else. Factoring is just one of the options of the something else you can do. The other videos will address the other options.